Hi, graphing a function rule today.
Okay, so we are going to graph equations that represent functions.
There you go.
Remember that functions can be defined as something as an input that only has exactly one output, or an output that has exactly one input.
There you go.
Okay, what is the graph of the function rule y equals 1/2 x minus 1? Well, first of all, I know this is a linear function rule
How do you know that?
because it's in a linear form of an equation that we haven't talked about yet.
Very good.
So,
It will come out to be a line.
spoiler alert,
Sorry.
it's coming up.
Okay, so here, this is all we're giving, and it says, what is the graph of this? Well, I don't know. So we need to figure it out. Okay, so you need to pick 5 values for x that you want to plug in and use. And that's it. You choose the 5.
But I think there's a method to our madness here.
But the 5 that we choose are.
It really can be whatever you want.
Yeah.
But I'm looking at this graph, and I probably am not going to want to pick 100, 101, 102. No. You're going to want to pick.
I always want to pick 0 because that's super easy.
That's a very easy one.
What other ones are really easy?
1.
Okay. And
-1.
Okay.
-2 and +2. So ultimately, guys, you could pick whatever you want, but if you pick these, it's going to be the easiest road to follow.
Yep. Now, I don't want to confuse you, but this is a 1/2 fraction. So let's say, I think there's one on your homework where it's 1/3. If it's 1/3, you would use multiples of 3 instead of multiples of 2 to make it a whole number.
Oh, I got it. So, okay, so in that case, we would have to do -3.
Or -6,
-6,
-3.
-3, 0. Got it.
Yep.
Okay.
So always use the old noggin.
Okay. So now all we have to do is plug and chug. So
Yeah.
we are going to take y equals, we're going to plug in -2 where x is, so times -2, and then -1.
Okay.
And then we just solve this bad boy.
So 1/2 times -2 is?
-1. I know 1/2 of 2 is 1, so it's -1. -1 minus 1 is -2.
So my ordered pair is -2, -2.
Yeah, so where'd you get that second -2 from?
Oh. I used this as my x value.
So
And then this was my y value.
Okay, so I see. So x, y. Got it.
Okay.
Okay, so now let's plop that -1 in there. Oh, you're going to graph it first?
Oh, no, I wasn't.
Okay.
I just happened to be over there.
Okay, so half times -1 minus 1. Boy, half of -1 is -1/2.
So -1/2?
Yes.
Okay.
Minus 1 is -1.5.
Yeah.
Okay, so this is going to be -1.
Which we got right here. -1 is our x, comma, -1.5, or 1.5. Same thing.
0. I love working with 0.
Zeros are awesome.
So we can't divide by 0, because then the world will explode. All right, so
0
minus 1 is -1. So now we have 0, -1.
And then we keep going. Y equals 1/2 times 1 minus 1 equals 1/2 minus 1. 1/2 minus 1 is?
-1.
Oh.
-1/2. Yeah. So 1 and -0.5. And then our last one, plug in 2 where x is. So 1/2 of 2 minus 1. So that's going to be 1 minus 1. Equals 2. So this is, equals 2. I did 1 plus 1. Whoa. So 2, 0. Okay.
So now, what do I do, Rich?
Well, now you're just going to plot these points. So -2, 2. I go to -2 on the x-axis.
So I'm done with all this,
You're
right?
done. You're
I just
done.
need this x, y column.
Yep, that's all we need. Okay, so I'm going to go to origin, go over to 2 on the x.
Over which way?
To -2, I'm sorry, which is to the left. And then you're going to go down to -2 on the y and put a dot where those two lines intersect.
So our point is -2, -2.
Yes.
Okay.
Okay.
Origin, -1, so that's left. -1.5, so that's 1.
And then halfway between those two. You can estimate, but it really should be halfway between.
Okay.
0, -1, so go to origin, go to 0 on the x.
So I don't go anywhere.
Nope, and then go down 1 to -1.
Okay.
Put a point. And then we've got 1 -1/2. So over to the right,
origin,
1.
Right, down 1/2. Okay.
And then over to 2.
Origin, over 2.
Up 0.
Up, done.
And then we would connect the dots.
Okay, now here's the thing with a straight edge. It's called a straight edge, so you use a ruler, your school ID, something that is hard and it won't give when you
Right, so not a
connect.
piece of paper,
Correct.
not the side of your calculator because that's
That's
rounded.
curved. So here we go. Straight line. My line takes up the entire graph,
Mhm.
and then I have arrows on the end.
Mm-hmm.
Guys, that's going to count for a point every single time. Straight line and arrows.
Yeah, so if you want a free point and you don't know what else to do, draw a straight
Straight
line on
line.
your graph.
With arrows.
Put arrows on it, you got a freebie right there.
You do. So that's all it is. You start with the equation that we have. You choose your x values that are compatible with what we're doing. Most cases you're going to use -2, -1, 0, 1, and 2, and then plug and chug,
Plop it on your
plot
graph.
one, and then have a straight line. Isn't this fun?
I like this
I
stuff.
do too.
All right, when you graph a real-world function rule, choose appropriate intervals for the units on the axes. Every interval on an axis should represent the same change in value. If all data are non-negative, show only the first quadrant. So ultimately, guys, if whatever you're going to skip by on your graph, you gotta do it everywhere.
Right.
And it needs to make sense for the problem. So if for example, we dealt with a problem yesterday about money, and it was cans, and there was like $52 and then $53 and $54.
Mm-hmm.
Anyways, so we needed to choose appropriate intervals for that. We wanted to skip by ones.
Yep.
And so we had to,
Make a break and
make
then
a-
go up
right.
by one.
Anyways, so this is just something that we need to remind you about that you need to do.
Yep.
So
Real world problem here.
it's about trucking.
About trucking. So the function rule, W equals 146C plus 30,000 represents the total weight, W, in pounds, of a concrete mixer truck that carries cubic feet of concrete, C. If the capacity of the truck is about 200 feet cubed, what is a reasonable graph of the function rule? So
Okay.
in our little box to the side, it says, how do you choose a real-world independent variable? So look for information about what the values can be. The independent variable C in this problem is limited by the capacity of the truck of 200 square feet, cubed feet.
Right. So we know that the weight depends on the concrete.
Right.
Right?
Right.
So concrete is going to exist whether I have a lot of weight or a little weight. The concrete is there.
Right.
So concrete is our deep independent variable. Weight depends on how much concrete there is.
Right.
Okay?
So if I start here with this real world problem, can I have -2, -1?
I don't think that makes a whole lot of sense.
Okay, because
Those are not appropriate intervals. We can't have -2 cubic feet of concrete.
right, but what's the lowest I could start with?
Well, you could have no
I
cubic
could have
feet.
none.
Okay.
Okay,
Then, okay, I'm probably, this is,
I'm trying to get up to what? What's the maximum I can have?
was it 200?
So
Okay, so
if I
the
do-
bottom one's 200.
So I want to create intervals from 0 to 200.
Right, so I'm thinking, well, what's 200 divided by, is it 5 or 4? 50, 100, yeah, so 50,
Mm-hmm.
then 100, and then 150.
Perfect.
Okay, so now we just plug and chug.
Right.
So the first one, W equals 146 times 0.
And guys, this is why we love 0.
Mm-hmm.
First order pair, 0. 30,000.
Mm-hmm. So I got the 0 from the C,
Mm-hmm.
and I got the 30,000 from solving that.
Yep.
All right, 146 times 50. Look what I brought today.
Yay.
It's pretty dark in here though. 7,300 plus 30,000.
50,
50 and 37,300
37,300.
would be the weight.
Okay.
Okay, then we've got 146 times 100, which I don't really need to do, but I'm actually going to do that just to be safe. Plus 30,000 is 44,600. So 100 cubic feet of concrete will give me a pound's weight of 44,600. All right, 146 times 150 plus 30,000. So it's going to be 150 cubic feet of concrete gives me 51,900 pounds in weight.
Okay.
Is it pounds?
Yeah.
Yeah, okay. And then the last one, 146 times 200.
So
Plus-
you guys should be filling all of this in.
Mm-hmm.
Okay.
We're doing the math for you.
Yep. You're welcome.
You're welcome.
We like gifts.
Sugar-free Red Bull is delicious. She likes
Diet Coke.
Diet Coke. All right, so here we go. We've got 200 for our cubic weight, and then we've got 59,200 for our W, which would be pounds.
Okay.
Okay, now we just plop it on the, okay, so now, remember the previous slide where it talked about how if you have any non-negative values in your ordered pairs, then you're only gonna show quadrant 1.
Right.
So that's all we've got here. So we've got concrete on the bottom because it can exist by itself without weight. Well, whatever.
Yeah.
And then the weight depends on it, so that's why. And then, okay, so we start at 0.
So I can jump by 25s, you think,
Sure. Well, are you going to get all the way up?
to 200?
Oh, yeah, you will. So here's another thing that I'm super picky about graphs. I do not want you to make a little dinky graph down in the corner.
No.
Spread it out if you can.
So I'm given this whole distance, so that's why I chose to skip and go by 25s.
Because then it's going to look better and it's going to be a lot easier to read.
It'll be easier for you.
That's way true. Okay, and then we're going to put our weight on.
So now I have to go up to about 60,000.
Okay.
So what do you think would be the easiest here? Should I make a break? Should I go by 10,000?
I think we should make a break because it doesn't even start until 30,000.
Okay. So I'll break it.
And start it at 30,000?
Okay. So I'm just going to put 30K. Is that okay?
Oh, that's a K. Yes,
Yeah.
that's fine with me.
Okay. And then up to skip 1 and go to 40?
Well, then we're still,
So
yeah.
40.
Yeah, that'd probably be all right.
50,
50,
60.
60. Sure.
Okay.
Sounds good.
So instead of putting the K's, guys, I could have in my label put thousands. I just ran out of room. And then I'd only have 30, 40, 50, 60 there too.
Okay, I mean, you got to kind of think. Okay.
Yep.
So now we just plug and chug. So 50.
So 0.
Oh, yeah. 0 gives me a weight of 30,000.
Okay.
So that must be, I can totally imply that if I have no cubic feet of concrete in my truck must
truck
weigh
weighs.
30,000 pounds. Okay, so then 50 cubic feet makes my truck now weigh 37,300.
About here. Because this line would be 35, so it'd be a little above it.
You're right.
Okay.
144,600.
So right below.
Right
the
below,
next one.
in between 40 and 50. 51,900.
So 51.
Just a tad bit, skosh above 50. And then the last one's
200.
almost to the 60, right?
Yep.
Wow, and look at this, really nice.
Looks like it's linear.
It is linear.
So it's a line.
But I also feel like it does say that we should connect the dots. So let's do it.
So only one arrow in this case. There you go.
Oh, and I understand because we could have 25 cubic feet of concrete.
Or
so
51.
Or 51, yeah. So I would want to know the values between. Okay, very good.
There you go.
Very good. Okay. Oh, here's what we're talking about. Connecting the dots or not. I love it.
Okay, you think we have no time?
Nope.
Okay.
Okay, so like we said, probably not going to have enough time. So we're stopping here. You need to do lesson check number 1.
Yep.
And we'll start with this tomorrow. Okay, we'll see you.
On the flip side.
Bye-bye.